In this video, we are going to learn how to use acceleration time graph and velocity time graph to find change in velocity and displacement. Example question 32. A car moving in the x direction has an acceleration a that varies with time as shown on the graph below. What is the change in velocity between t equals 0 and t equals 8 seconds? If you have acceleration versus time graph and they want you to find velocity from this graph, then you need to take area under the graph to find the change in velocity or the magnitude of velocity. Similarly, if you have velocity time graph and they want you to find position or displacement, again you need to take area under the graph in the given time interval to find these values. So I have acceleration versus time graph. To find the change in velocity delta v, I'm going to take the area under the graph. So we take the area going from time t equals 0 to time t equals 8 seconds. So I'm basically looking at the area from 0 to 8, this area within the graph. And the shape of this region is a triangle. So when I take the area, I take area of the triangle, which is half times base times height. Base is the value on the time axis. So if you look at time axis, my triangle goes from 0 to 8 seconds. So base is 8. And the height is the value on the acceleration axis. So you're going from 0 to 6. So your height h is 6 meter per second squared. I will substitute that here. Half times 8 times 6. That gives me the change in velocity to be equal to 24 meter per seconds. So anytime you have acceleration versus time graph and you need to find velocity, or velocity versus time graph and you need to find the position or displacement, you have to take the area under the graph. Example question 34. A car is moving along the x-axis and its velocity Vx varies with time as shown in the figure. If x0 is equal to 2 meter at t0 equals 2 seconds, what is the position of the car at t equals 10 seconds? So here I have the position values when time t was equal to 2 seconds, which is x0 equals 2 meter. And I want to find what was the position at 10 seconds. Now, as discussed before, here I have velocity versus time graph and I want to find the position. So to do this, we take the area under the graph. Here I already know the position at time t equals 2 seconds, which is x0 equals 2 meter. To find my position at time t equals 10 seconds, I will start from time t equals 2 seconds and go until 10 seconds. Because we already know the position at 2 seconds, we need not take the area under the graph before 2 seconds. You can start from 2 as your initial point and go until 10. So we take area of this region highlighted here. Whenever you are finding displacement or position or velocity values, only take area under the graph for the given time values. So here I'm starting from 2 seconds to 10 seconds. So I will take area under that region only. So here my area under the graph is covering 3 regions. This is region 1, then this is 2, and this is region 3. So when I find the area under the graph to find position, I have to take all of these 3 regions. So my position x will be area under the graph plus the initial position. I'm adding this initial position because we are starting at time t equals 2 seconds. And at time t equal 2 seconds, my position value was 2 meters. So we need to add that value to our area. So we get x equals, there are 3 triangles here. So I will write area under 3 triangles. Half times base of the first times height of the first plus half base of second times height of second plus half base of third times height of third plus x0. Now we solve for this. Base of the first triangle is going from 2 seconds to 5 seconds. So my base B1 will be 5 minus 2, which is 3 seconds. Height of the first triangle is 12 since we are going from 0 to 12. So we can write that here. Half B1 is 3, H1 is 12 plus half. Then we find the base of the second triangle. It is starting from 5 and going until 8. So your base B2 will be 8 minus 5. You can calculate base for any triangle by taking the final value minus the initial value. So here the base will be 3 seconds. Height of the second triangle, you're starting from 0 and going until negative 4 here. So H2 will be negative 4. Substitute that times 3 times negative 4 plus. Then for the third triangle, it is starting from 8 and going until 10. So my base B3 will be 10 minus 8, which is 2 seconds. And the height of the third triangle is 4 meter per second. So H3 is 4. We substitute that. Half times 2 times 4 plus x0, which is 2. And when you solve this, you get position at 10 seconds to be equal to 18 meter. So all we did was find area under the graph plus the initial value to find position at 10 seconds. Example question 35. A car is moving along x-axis and its velocity vx varies with time as shown in the figure. What is the displacement dx of the car from t equals 4 seconds to t equals 9 seconds? Again, here you have velocity versus time graph, and they want you to find displacement delta x. Displacement from velocity versus time graph is the area under the graph. So first we locate the region within my time interval over which I have to find the displacement. The time interval is from t equals 4 seconds to t equals 9 seconds. So find t equal 4 second in your graph from 4 second to 9 second. This is the region where I have to find the area. Again, this region is into three parts. This is region 1, this is 2, and this is region 3. So when I have to find area under this region, I will write delta x equals. Each of these three regions is a triangle. So I will write half base of 1 times height of 1 plus half base of 2 times height of 2 plus half base of 3 times height of 3. Now find the base and height values for each of them. Base of triangle 1, it is going from 4 seconds to 5 seconds. So it will be 5 minus 4, which is 1. And the height is 4 because we're going from 0 to 4. Then base of triangle 2, B2 is from 5 seconds to 8 seconds. So 8 minus 5, which is 3. And height of this triangle is negative 4. So I will write H2 is negative 4. Then for the third one, you're going from 8 to 9. So B3 will be 9 minus 8, which is 1. And the height, it's in between 0 and 4. So we can take that height to be 2. Now substitute. You get delta x equals half times 1 times 4 plus half times 3 times negative 4 plus half times 1 times 2. And when you solve this, you get your displacement delta x to be equal to negative 3 meter. When you're calculating the values of displacement or velocity, which is a vector quantity, you have to take the terms which are negative as negative. You cannot switch the sign and make it positive. Vectors can be positive, negative, and 0. So if you're finding a vector quantity from the graph, if the region in your graph goes to the negative sign, you have to take negative values for those part.